Hi, this is OrgoChemSimplified, and here we have a mechanism problem. Here we have a double bond to an NH with a methoxy group. We're reacting that with simple OH minus, and we get this amide out with an additional methanol. So the problem is, what is the mechanism to go from here to there? So we know we have an OH minus, and that's going to react. And how is it going to react? Well, the only real option we have is to react as a nucleophile. So what's the most nucleophilic atom? It's this carbon that's double bonded to the NH. It's basically like a carbonyl carbon, because in a carbonyl carbon you have a carbon that's double bonded to a more electronegative atom, which is oxygen. Now it's just nitrogen, but it reacts in the exact same way. So what do we get? This OH will attack that carbon, and it will kick up that pair of electrons to form a tetrahedral intermediate. So we have an OMe, an OH, and an NH minus. Okay. Now that we have this compound, we know nitrogen is more basic than oxygen, so this nitrogen will actually get protonated and that oxygen will get deprotonated. So this nitrogen will grab a proton, probably from water, and this OH group is going to get deprotonated. So now what do we get? We just have a shuffling of hydrogen atoms and this OMe group here. Okay, so now we got the tetrahedral intermediate we're used to seeing, where we have an O minus and two other groups, right? So what happens when we have this tetrahedral intermediate? Well, we know that this pair of electrons tends to come down, right? And it tends to kick out one of the three groups attached to the carbonyl carbon, or the newly formed carbonyl carbon. So this is the carbonyl carbon. So we can either eliminate out OMe, we can eliminate out NH2, or we can eliminate out the CH3. Well, carbon-carbon bonds are very stable, so that's out of the question. Now what's the question? Are we going to eliminate the NH2 or the OMe? So looking at the product, you can already tell you're going to eliminate out the OMe. But let's see why. Right? So why is this going to happen? Well, what's the pKa of methanol? It's roughly 17. And what's the pKa of ammonia? So these are pKh's, right? And so what is this telling you? This is telling you that the methoxy group, MEO-, is much more stable in solution than NH2-, right? So which group is going to get eliminated is the one that's most stable by itself. And clearly from the pKa's, you can tell that it's going to be the methoxy group, right? So once we perform that elimination, we get our product. And we arrive at our answer. So hopefully that was clear. Hopefully that helped. The real only tricky parts was this proton shuffling. Once we had that proton shuffling, the tetrahedral intermediate was pretty straightforward. So if you liked the video, if it helped you, please spread it. My goal is to help as many people as possible. So if you liked it, please help me. Thanks for watching.